Support comes from Missouri Forest Products Association, committed to sustainable and sound conservation of the state's forests, which support more than 41,000 Missouri jobs, resulting in a $10 billion industry. ChooseWood.com.
This is St. Louis on the Air from St. Louis Public Radio. I'm Elaine Cha. Today, we want to bring you an episode from the 5-part podcast series, A CRISPR Bite, which explores how and why biotech companies are using CRISPR technology to change our food. A St. Louis company takes center stage in this episode. Here's host and food anthropologist Lauren Crossland-Marr.
I'm in my local grocery store in Oceanside, California, looking for meat alternatives. You know, like soy patties and tofu dogs. Let's see, we have veggie burgers, spicy chicken, made with soy protein concentrate. I'm here because increasingly companies are using CRISPR gene editing technology to engineer products to have more protein and to taste better. Far from all meatless products on the market today are manufactured with CRISPR, but it is a technology some companies see as a game changer. They argue that CRISPR offers a faster and more precise way of creating meat alternative products. Oh, look at this one. Meatballs, classic meatballs made with whole plants. Oh, I love meatballs. And the ingredients, non-GMO, excellent source of fiber, breaded vegan shrimp. Wow, you can really have everything. It's huge. There's got to be over 100 products here. I ended up leaving the store without buying anything. Not even the soy-based meatballs. Plant-based meat products just really aren't my thing. But I did wonder, why are plant-based meat alternatives suddenly everywhere? This is A CRISPR Bite, and I'm your host, Dr. Lauren Crossland-Marr. In this episode, I'm taking you into the burgeoning world of plant-based protein products.
Here, what they're doing is they're actually making soy milk.
I'll explain how one benefit of CRISPR could be increasing the amount of protein in plants. And some proponents say it could even reduce the effects of climate change. And this story is also about how our food system developed in the first place. To learn more, we discuss Norman Borlaug, a charismatic and controversial figure in the development of modern agriculture. The market for meat and dairy substitutes of all kinds is taking off. That's according to a Michigan State University study that showed plant-based meat consumption is on the rise. The more than $6.5 billion industry is expected to increase to more than $16.5 billion in 2026. That means companies are anticipating lots more consumers demanding these kinds of products. Plant-based meat alternatives are a big trend now, but there's one burger in particular that brought these kinds of products into the mainstream.
Burger King has just announced that it'll roll out the plant-based Impossible Whopper to
The Impossible Burger claims to be the world's only plant-based burger that looks, smells, cooks, and tastes like a regular beef patty.
However, a plant-based patty that's quickly gaining popularity may make the impossible possible.
At the time of this taping, the company behind the Impossible Burger, Impossible Foods, is valued at more than $7 billion. Their products are sold in restaurants, supermarkets, and even on airplanes now, and people love them. There are a lot of reasons more people are switching over to plant protein. Climate change, food allergies, and health. It's a huge market opportunity if companies can get products right. The Impossible Burger was really just the start of this big trend, and it's got a lot more competitors today. One of them is a startup company called Benson Hill. 2 years ago, I got an inside look at what the process of making CRISPR-edited plant protein looks like there. The 10-year-old company went public in 2021 in a multi-billion-dollar deal with Stark Peak Corporation. It's taking off with the help of artificial intelligence, machine learning, and CRISPR to make meat alternatives made from soy and yellow peas.
So here we go.
I was curious to see how it all works, so I drove to a suburb outside of St. Louis to tour Benson Hill's lab. Their soybeans made with CRISPR are still in the research phase, but the company has been selling ultra-high protein soybean ingredients created without gene editing for over a year.
Turn right onto North Corson Road, then the destination is on your right.
About 30 minutes west of St. Louis, there's a big industrial complex that houses a lot of companies working on agricultural innovations, including Benson Hill. Inside the headquarters, the lobby is large, with a multi-level ceiling and an open staircase. Plants dot the space, giving life to the concrete and glass interior. A Benson Hill employee led me deeper into the office.
Hey, are you Melanie? Hi, nice to meet you. I'm Lauren.
There's brightly colored areas sparsely populated that show the startup vibe of the office.
I see green is the theme here.
You'll see it throughout the building.
There's also a game area and a library, but at this time in the morning, it seems all the employees are hard at work. And that's where I met Matt Begeman.
So I lead gene editing and trait discovery at Benson Hill.
To him, creating soy products is personal.
So here at Benson Hill, what we're doing is using natural genetic diversity to create new products. Care about new products for both the farmer and the consumer. My family farms in western Missouri. They farm soybeans. I have a daughter who's got a dairy allergy. So she is a connoisseur of soy yogurt, soy milk, all types of soy products. So I'm right in the middle of this.
Matt pointed to a poster behind him showing pictures of different types of soy plants. One of them is a commodity soybean, the kinds that are typically grown in tight rows to optimize for yield, which means getting the most quantity possible. This is the norm for soybean farming, but Matt and his team at Benson Hill think that yield is actually the wrong goal. Instead, they're growing soy to be as nutrient-rich as possible, even if it means they end up with fewer plants. He says the industry's emphasis on pumping out as much soy as possible, regardless of the quality, has made his job a lot harder. Typical commercial soybeans only have about 35% protein. That's much less than soy plants used to have 6,000 years ago. That's because the protein content decreased as farmers domesticated the soy plant over generations.
But the protein content of this wild ancestor is anywhere from 45 to 55% protein. And at the end of the day, it's the protein that's the product that we're after for a plant-based burger, a dairy milk, anything like that.
For Matt to be able to mass produce soy products, he needs as much protein in his soybeans as he can get. So his lab is looking at more protein-packed ancestral soy varieties with the goal of creating new varieties today that offer more nutrition. These could be different depending on whether they're making a soy burger, soy milk, or something else. CRISPR is really helpful in this process because for scientists, it is a lot faster than breeding techniques. They can see if a change worked without having to wait for a plant to grow fully, taking experiments down from 9 months to just a few weeks. Also, scientists say they can target the specific genes responsible for protein production. By comparing the genes of more protein-producing varieties, they can turn on or off the genes responsible for protein in industrial soy varieties. With CRISPR, Benson Hill can look at the protein-packed varieties of soy that may not be suitable for industrial farming and add more protein by targeting those genes that differ. And this is huge because it means you can genetically add more nutrients to crops. Matt led me into the lab to show me how this all looks in practice.
So come on in. So we built this space, we got to design this space from the beginning to meet our needs.
It's a bright room and all the walls are made of glass, so you can see the scientists working. This is very different from the labs I've seen in universities, which are usually found in dark basements. I see lab technicians wearing goggles and lab coats, staring at computers or microscopes. They're using robot arms, joysticks, and chambers to do their research. Matt explained they're trying to automate the process.
So we've got something like a liquid handling robot here that can do a lot of the pipetting. So, in a lab where you have less automation, there's people where their job is moving around the liquid into the different plates. I mean, you've seen those types of labs before. And it's a lot of tedious work. And honestly, as people, we make mistakes.
Time is an especially important commodity in this process. And nature can provide some serious challenges. Growing plants in a greenhouse takes time and space, and this automation helps them cut down on both and figure out which soy plants they want to focus on. We crossed the open part of the lab and walked into a back room where scientists surrounded by petri dishes peered into a microscope.
So I know it's noisy in here.
It's loud, so we raised our voices to hear each other. Matt says this is where they work on the flavor of the products.
And over here, what they're doing is they're actually making soy milk or yellow pea milk, and we'll measure the flavor, and I'll show you how we do that.
Flavor seems so subjective.
Yes, it is. So part of what we're doing is connecting what someone perceives as a good or a bad flavor, and then can we understand that molecule that creates that good or bad flavor? This is liquid chromatography followed by mass spectrometry. This allows us to separate out the different amino acids that might make up that protein fraction. We can also measure compounds like saponins and isoflavonoids, which are sometimes functional compounds, but they can also contribute a bitter flavor to soybean.
So you don't want those?
Depends on the product, right?
Right.
So this is gas chromatography followed by mass spec, and so that pea milk or that soy milk I was showing you in the next room, it comes here and a needle will go in and extract the air on top of it, run it through this machine, and we'll measure 14 different flavor compounds associated with that pea or soy milk that we've created. And so what we can do is, we can generate all of this flavor data on all of our different soybean varieties, natural genetic diversity, or breeding material, figure out what contributes to flavor, and now we can design new soybean varieties through breeding or gene editing that have the flavor profile or the food functionality profile that we're looking for.
Very cool. And so 14 is a lot more than sweet, sour, salty. So what are some of the other flavor profiles you're looking at?
So, if you think about plant-based foods and what turns you off from them, it's beanie flavors, oxidized cardboard flavors, grassy flavors. And those are the types of flavors we're moving away from, and we're trying to bring in some of those sweeter, savior flavors that, we tend to prefer over or beanie grassy.
Basically, Benson Hill is trying to think about what individual consumers want. What makes them willing to eat a plant-based alternative over meat? What flavors and textures do they want? But maybe more than that, I was interested in why. Why are they investing so heavily in plant-based meat alternatives? And why are they using CRISPR to do it? I walked down the hall to speak with Benson Hill's Chief Technology Officer, Jason Bull, to find out more. We dove into talking about food straight away while I set up my audio equipment.
So what did we eat for breakfast?
Oatmeal with raisins. I like it. And it's really easy.
The instant oatmeal is what you're using?
I do, instant, 1 minute and 12 seconds, in fact.
You've got it down to a science, and I'm not surprised. Once I'm all set up, we start talking about what stands out about Benson Hill as a company. He says the company is going against the industry's focus on just yields, and instead are more focused on nutritional quality.
And really what we're doing is kind of undoing what the commodity system has done to our crops. So we're taking genes that have been muted in the commodity system and bringing them back to life so that we get that flavor and functionality that restored in the crop. So using natural genetic variability, but just targeting it using CRISPR.
So what is the system he's talking about? Well, here's a quick history lesson about a plant geneticist from Iowa and poop. For 100 years, the agricultural system relied on guano, also known as bat and bird poop, for fertilizer. But this changed after World War II when a shortage of guano led to innovations in fertilizer technology. Also, during World War II, the United States heavily invested in companies producing nitrogen as ammonia because this was a major ingredient in explosives. In the 1940s, scientists figured out how to apply nitrogen without blowing up fields, and the modern fertilizer industry was born. This set the stage perfectly for the charismatic Norman Borlaug. Beginning in the 1950s, he devoted his life to feeding more people, and his solution was pretty simple: help farmers grow more plants more quickly, and this is also known as increasing yields. Borlaug died in 2009, so I didn't get a chance to interview him. But here's him giving an acceptance speech in 1970 for winning the Nobel Peace Prize for his work. At one point, he stresses his core philosophy, the need to use agricultural technology to increase food production in order to keep up with population growth across the world.
For we are dealing with two opposing forces: the scientific power of food production and the biologic power of human reproduction. Man has made amazing progress recently in his potential mastery of these two contending powers.
Borlaug's ideas for increasing yields sparked what's known as the Green Revolution and the modern farming system in the United States. Here's a clip from an educational documentary from 1971 about Borlaug.
Peace is more than the absence of war. Peace is the absence of hunger. The Green Revolution is a bloodless battle. It's the fight against famine and the fight for improved agricultural production. This is the first time the Nobel Prize for Peace has been awarded to anyone in the field of agriculture. Dr. Norman Borlaug's revolutionary attempts to improve wheat strains have done much to ease the pangs of world hunger.
Borlaug was obsessed with quantity over everything else. He had good intentions to feed more people, and farmers did produce more crops for a short time, but the conundrum is, well, during that time people still starved to death. Turns out that Borlaug's equation wasn't so simple. More crops doesn't inherently mean that less people are hungry. Take, for example, the Irish potato famine. During that time, millions of people died and immigrated, but Ireland was still a major exporter of meats and vegetables to England. All this makes Borlaug's legacy controversial. While Borlaug's ideas did avert food shortages for a while, they didn't end starvation like he said they would. Some say the varieties of crops he created actually may have worsened poverty in the world. That's because the shift to industrial agriculture relied on more inputs like fertilizer, tractors, seeds, and pesticides. This reliance left a bigger financial burden on farmers and made them dependent on a monoculture. For example, while farmers had previously grown a variety of crops, under the new system, they focused on just one, making them more vulnerable when things go wrong, like a drought, an intense storm, or a flood. People in industrial agriculture see Borlaug as a hero who laid the foundation for the system we have today. Others, not so much. One thing that's clear to me is that Borlaug had a profound impact on industrial farming. He started a movement that emphasized quantity over nutritional quality, which led to using more natural resources and creating less healthy soil. Basically, the farming system we have now isn't sustainable, and this template for growing plants was also applied and used for raising animals for meat, giving birth to the industrial meat farming industry. Today, 98% of soy isn't even grown for human consumption, but for animal feed. Spoiler alert, this is all really bad for the environment. Just to be clear, I'm not talking about the meat you buy at the farmer's market, but the 4 companies that own over half of the meat production industry in the United States. That's Cargill, Tyson Foods, JBS, and National Beef Packing. The industry is responsible for about 15% of global greenhouse emissions, according to the United Nations. And beef is the biggest offender, producing more than half of these industry emissions. Emissions that lead to climate change is why many in the plant protein industry believe their products can help consumers move away from eating meat. Industrial meat production is bad, and Benson Hill CTO Jason Bull says meatless protein will help solve that problem.
You just step back and you think, well, there's just got to be a better way. I mean, the food system that we've put in place over the last 20 years has been tremendously successful, and yet there's still these big gaps from where we want to go. And that's what really, got me excited about Benson Hill, because we're taking a different approach. We're not a seed company. We contract with growers to create a nutritionally enhanced crop that we then crush and sell the ingredients downstream. And those nutritionally enhanced outcomes have a material impact in terms of impact on the environment being far less. They're not going through an animal feeding step to create protein, which is incredibly inefficient. Instead, we're creating it in a plant. And that's hugely exciting to me and exciting to see the impact on that in the next 10, 20 years.
Borlaug's dream was to feed a growing population, and Benson Hill also has lofty goals. Bull says more soy products means less meat consumption, and that's better for the environment. He believes that by cutting out the animal part of the protein equation, the company is helping reduce emissions that contribute to climate change. I generally felt the passion for creating something better at Benson Hill. This is a group of smart people finding ways to make products for a growing demand for meat alternatives. Benson Hill and companies like it are doing a lot by pushing the agricultural industry away from purely focusing on quantity. To me, that at least has the potential to have a positive impact on our world. They're using CRISPR to make tastier, better food for consumers, which I think is a good thing. But I also couldn't help but think that Benson Hill's loftier goal of helping the environment felt a little like corporate greenwashing. I'm not sure Benson Hill is bucking the system in the way its employees believe they are. Even with the improvements CRISPR offers, the company still needs large-scale farms that have a lot of inputs like fertilizer to produce more soy to meet a growing market demand. Meat production is no doubt the worst thing for the environment, but even turning toward CRISPR protein-packed plants still has a lot of downsides. Large-scale farms of any kind would likely still destroy soil nutrients, use harmful chemicals, pollute groundwater, and require a lot of water to grow plants. It might be slightly better, but it's not the perfect solution to climate change. Replacing meat with soy products might just be moving around the problem instead of solving the core issue. And that's that our agricultural system isn't sustainable. And there's no magic technological solution. We have to consume less and eat locally. Basically, I'm suspicious that CRISPR is the silver bullet solution to climate change. But I'm not totally against the soy stuff. If it tasted good, I'd give it a try. But it's not what would make me sleep well at night. It wouldn't make me feel like I'm doing my part to reduce climate change.
That was the third episode of A CRISPR Bite, a new podcast that explores how gene editing technology is changing our food. A CRISPR Bite is produced by JEEP3, an international social science research consortium, and by executive producer Corinne Ruff. This episode was co-written and hosted by Lauren Crossland-Marr, edited by Jake Harper, and fact-checked by Maya Singos, with sound design and engineering by Adrian Lilly. Aaron Crossland made A CRISPR Bite's theme music.
This episode was produced by Emily Woodbury.
Audio engineering and podcast design by Aaron Dorr.
Our executive producer is Alex Hoyer.
St. Louis on the Air is a production of St. Louis Public Radio. Understanding starts here.
St. Louis on the Air proudly supports local artists by using music from Life Creative Group.
Do you find yourself regularly listening to episodes of St. Louis on the Air? Suggest us to a friend you think might enjoy our conversations. And leave us a review and rating on Apple Podcasts on the App Store. It's the simplest way to help people discover our show. Thanks.
St. Louis Public Radio is a member-supported service of the University of Missouri St. Louis.
Support comes from the Missouri Forest Products Association. Missouri produces wood pallets, railroad ties, white oak barrels, hardwood floors, and more. Details on the variety of products made in the state are at choosewood.com.